Okay, Module 3, Vulnerability Management. Common vulnerabilities: improper software exception and error handling, insecure external components and functions, faulty configurations, broken authentication, inadequate monitoring. Improper software exception and handling increases the risk of sensitive data exposure, disclosing sensitive data to attackers. Vulnerabilities in software are often the result of poor coding. As you remember me on several different sections talking about, this is why if you see this XYZ leading to like cross-site scripting errors and things like that, then it means that your coder wasn't paying attention or they didn't have peer review. When it comes to software, it's the same kind of thing. If you don't have good base code, then you are going to have a lot of vulnerabilities. Improper error handling, improper trapping of an error condition, potentially providing attackers with access to underlying operating system. Another thing that can happen with improper error handling is sometimes those error messages can give you a lot of information about what exactly is causing the error, and then it gives the attacker some information on how they can force programs into that error state. When an application dereferences a pointer that it expects to be valid, but instead has a value of null, it typically causes a program to crash or exit. Race condition: two concurrent threads of execution access a shared resource simultaneously. Insecure object reference: an application externally exposes a reference to an internal object. I'm just going to go right past those discussion ones since this is just to record because I had some committee meetings. Insecure external software components: application program interface or API, link provided by an OS, web browser, or other platform that allows a developer access to resources at a high level. Device driver: software that controls and operates an external hardware device connected to a computer. Specific to both the OS and hardware device, device driver manipulation, attack characterized by threat actors attempting to alter your device drivers. Dynamic link library or DLL. This is a repository of code and data that can be used by more than one program at the same time. Insecure internal functions and faulty configurations. Programmers who choose internal programming language functions can introduce vulnerabilities. strcopy internal function in the programming language C can be used to copy a string to a destination buffer, does not check the length of the destination buffer into which the string is being copied. Weak configurations caused by improper implementation of configuration settings in hardware and software platforms. Okay, so here's a table of weak configurations. There's the configuration, explanation, and example. Default configurations. We've gone over this several times, so this is it in relation to this. Default settings that are predetermined by the vendor for usability and ease of use, and not security, so the user can immediately begin using the product. A router comes with default password that is widely known, as an example. Open ports and services. Device and services are often configured to allow the most access so that the user can then close those that are specific to the organization. A firewall comes with FTP ports 20 and 21 open, which, as we've talked about, they're not secure unless you have them shut off or you have them properly configured. Unsecured root accounts. A root account can give users unfettered access to all resources. An example is a misconfigured cloud storage repository could give any user access to all of the data. And there's actually been several like data breaches. I don't know if you've ever seen those ones where they're like, this Amazon cloud repository. This is exactly what happens in those cases. Open permissions. Open permissions are user access over files that should have been restricted. Example, a user could be given read, write, and execute privileges when they should have just been given read privileges. Unsecure protocols, also called insecure protocols. Unsecure protocols for telecommunications do not provide adequate protections. Example, a network administrator could use devices that run services with unsecure protocols like Telnet or SNMP version 1. Weak encryption. Weak encryption results from choosing a known vulnerable encryption mechanism. A system administrator could select an encryption scheme that has known weaknesses or a key value that is too short. So like if they're using an MD5 instead of any of the AES configurations would be an example on that too. Errors. Errors are human mistakes in selecting one setting over another without considering security implications. A user could use depreciated settings instead of current configurations. Broken authentication and inadequate monitoring and logging. Poor authentication practices that introduce vulnerabilities result in the opening of broad pathways that threat actors can exploit. Typical network-based poor authentication practices: storing user credentials using general-purpose hash algorithms instead of key-stretching algorithms, exposing session IDs in a URL, failing to force session values to expire after a set period of time or at logout, reusing session IDs after a successful login, sending passwords, session IDs, and other credentials over an unencrypted connection. Monitoring audit logs for signs of potential cybersecurity threats can be difficult. It may lead to insufficient monitoring and logging. One solution to this is to automate logging and monitoring processes. This helps remove that human error factor in, oops, I didn't turn on this particular logging section, or I didn't know that this needed to be turned on, or I have new software. You know, there's all sorts of things that can happen, and sometimes having those automatic logging and monitoring processes are significantly faster and more accurate. Vulnerability scanning. So penetration test, single event using a manual process often performed only to comply with regulatory requirements. Might be forgotten until next time it's required. In fact, that should read often forgotten until next time it's required. A vulnerability scan, frequent and ongoing process, often automated, that continuously identifies vulnerabilities and monitors cybersecurity progress. Involves being aware of decisions to be made regarding scans, running a scan, and analyzing scan reports, remediating uncovered vulnerabilities. So vulnerability scans versus penetration testing. So penetration testing first, and then vulnerability scan and then penetration testing. So the purpose: reduce attack surface, identify deep vulnerabilities. Procedure: scan to find weaknesses and then mitigate, and then act like a threat agent to find vulnerabilities to exploit. Frequency: usually ongoing scanning and continuous monitoring, and with penetration testing when required by regulatory body or on a predetermined schedule. Personnel: internal security personnel, and I think what they mean here is who the people are that do this. And then penetration testing, external third parties or an internal security personnel. Process: usually automated with handful of manual processes. Penetration testing is an entirely manual process. What is the goal? Identify risks by scanning systems and networks, gain unauthorized access, and exploit vulnerabilities. Final report audience: executive summary for less technical audience, technical details for security professionals. And penetration testing. Usually you have several different audiences, and often you have to make a couple of different reports aimed at those audiences. Reasons for conducting a scan. to meet regulatory requirements, involve following specific actions mandated by external regulatory bodies. For example, whenever you deal with any sort of financial data, there's the PCI DSS, or the Payment Card Industry Data Security Standard. Several terms are used to describe the rules for an organization. A standard is a collection of requirements specific to a system of procedure that must be met by everyone. A guideline, set of recommendations that should be implemented. A policy, a document that outlines specific requirements or rules that must be met. Communicates a consensus of judgment. Defines appropriate behavior for users. Identifies tools and procedures that are needed. Now, oftentimes, not only does it have appropriate behavior for users, but sometimes you'll have examples of what are considered inappropriate behavior and, punishment or reactions to what those inappropriate behaviors, when those inappropriate behaviors happen. Provides directives for human resources actions in response to inappropriate behavior, may be helpful if it is necessary to prosecute violators. And a lot of times, if you have any sort of something with your personnel, you have to have some sort of policy to point to. That's also why they're required. To adhere to corporate policies, a vulnerability scan may be necessary. It helps an organization in meeting its goals as outlined in its security policy. Challenges associated with vulnerability scanning. Volume of scan data. Yes, it can be quite a lot. Identification of the vulnerability, remediation of the vulnerability, and sometimes technical limitations. Scanning decisions occur prior to conducting a scan. Decisions involve determining what should be scanned and how it should be scanned, when the scan should occur. Data classification. This helps determine what should be scanned by assigning labels to types of data. A vulnerability scan can be made to primarily focus on critical data elements while not neglecting other data elements. Classification of typical commercial data. There's the public, which is data that would cause only a small amount of harm if disclosed. Sometimes they also list this as what's called directory data because it's published oftentimes in a directory. There's proprietary data disclosed outside the company on only a limited basis to trusted third parties. Private data that might not harm the company itself but could cause damage to others. Confidential data used internally within the company. There's sensitive, and that's data that could cause catastrophic harm to the company if disclosed. And that's how you remember the difference between confidential and sensitive. Catastrophic harm. Government data classification. So you have top secret, secret, and confidential. Asset criticality involves determining the location of important data. Ensures that specific assets with high value data can be scanned more frequently. Types of vulnerability scans over assets. There's the network vulnerability scan. Scans can identify possible network security attacks and vulnerable systems on wired networks. Endpoint scans can locate and identify vulnerabilities on servers, workstations, or other network endpoints and provide visibility into the configuration settings and patch history of the endpoints. Wireless network scans can identify rogue access points and validate that the wireless network is secure. Database scans may identify the weak points in a database. Application, web applications, and other software assets can be scanned to detect known software vulnerabilities and erroneous configurations. Organizations can create a list of systems to be scanned by consulting an asset inventory, a list of all significant assets. Most vulnerability scanning tools allow for an inventory scan that only searches for devices attached to the network. Now, I'm going to make one note here when they talk about significant assets. A lot of times, organizations will put a dollar value on what items they want to put asset tags on. So, for example, they'll say any item over $250 has to have an asset tag on it. Because otherwise, if they did every single purchase with an asset tag, it would be insane to try and keep, track of everything. It's already difficult as it is with items of that nature. Network segmentation. This helps thwart lateral movement by threat actors. Low-risk segments may have fewer restrictions, while high-risk segments are more heavily protected. Enumeration. Extraction of data such as device names, IP addresses, OS version, installed software, and patches applied. Intended to build a picture of the endpoint and network. It's also known as mapping. Active versus passive scanning. Active scanning sends test traffic transmissions into the network and monitors the response of the endpoints. Passive scanning listens for normal traffic to learn the needed information. Internal versus external scanning. Internal vulnerability scan performed from the vantage point of inside the internal network. This identifies at-risk systems. External vulnerability scan performed from the vantage point of outside the network. This one is for detecting open ports and protocols. Frequency of scanning. The optimum frequency for vulnerability scanning is continual. Scan all times, all systems all the time. Constraints might require companies to scan on a routine basis instead of continually. Technical constraints, limitations based on technology can dictate how frequently the scan is performed. Organizations with large networks that have many devices may not be able to scan the entire network within a desired time period. A lot of times when it's something like that, they'll have like a step down tier of these are the items that we want to have scanned continuously. These are the items that we want to have scanned weekly. These are the ones that we want to have scanned monthly, and so forth. Workflow interruptions. Continual vulnerability scans may affect daily workflow or normal business. Moving scans to off hours, such as nights or weekends, can limit interruptions. Regulatory requirements. Specific regulations can dictate how frequently a vulnerability scan must be performed. Risk appetite, a company's tolerance for exposure to a vulnerability. Systems with sensitive data for which there is a low risk appetite may be scanned often. Running a vulnerability scan. Running a vulnerability scan comprises 3 steps: updating the vulnerability scan software, configuring the software, and executing the scan. Software updates enhance its functionality to provide stronger security. Vulnerability scan system updating includes plugin updates and vulnerability feeds. Plugin updates. As attacks continue to evolve, vulnerability scan software must be nimble so that information about new attacks can be regularly added and updated. Many vulnerability scan products are modular instead of being contained in a single enormous software package. Modular updates, also known as plugins, can be downloaded and installed as needed. Plugins generally go beyond basic updates. Many plugins contain advanced vulnerability information, a set of remediation actions, and updated algorithms to test for the presence of security issues. Vulnerability feeds. Vulnerability scanning software looks for the presence of a vulnerability by comparing the software it scans against a set of known vulnerabilities. Known as signature-based monitoring because it compares activities against a predefined signature. Signature-based monitoring requires access to an updated database of signatures and a way to actively compare and match current software against a collection of signatures. Vulnerability feeds provide updated information to scanning software about the latest vulnerabilities. Some of the best known vulnerability feeds are NIST National Vulnerability Database, MITRE common vulnerabilities and exposures. Anytime you see those CVE numbers, that's where that is. CERT, vulnerability notes database, and VulnDB. Configuring the scanning software involves setting specific parameters so that the scan meets the intended objective. Parameters include scope, sensitivity levels, and data types. The scope of a vulnerability scan defines the target devices to be scanned, generally includes a range of hosts or subnets. The scope of a scan should be designed to meet its intended goals. Example, if a specific vulnerability for Windows 10 computers is being targeted in the scan, make sure it makes sense to scan only Windows 10 systems. So there's no reason you should be like, I want all Windows 10 and XP and 11. You're just saving yourself time by actually selecting the correct things. Limiting the scope can also reduce the impact on overall network performance. The sensitivity level is the depth of a scan. It determines the type of vulnerabilities being searched. A general scan may search for all vulnerabilities, but a scan often looks for a specific type of vulnerability. A sensitivity configuration variable can be used to limit how deeply a system is examined. Scanning data types, used to, quote, drill down when searching for a specific vulnerability in a known file type instead of searching all the files on a system. Executing the scan. Different scanner options can affect the execution of the scan. Server-based versus agent-based scans, credential versus non-credentialed scans. Before attempting a scan, scanner permissions and access should be reviewed. Other network appliances should be properly configured. Scanner permissions and access. Well-protected networks should hinder or block a scanner from performing a vulnerability scan. The network security would prevent the scanner from accurately examining devices on the network. The network security should be granted appropriate scanner permissions added to access network devices. An additional set of scanner permissions is needed for a user to access and use the scanner itself. Scanning can uncover significant vulnerabilities. If a scan is conducted on a system not owned by the organization, the tester could gain access to the system through the vulnerabilities found. Results in serious legal and ethical issues, and testers should have permissions to use the software, but only access approved systems. This is why if you're doing any sort of white hat hacking or vulnerability tests or penetration testing, it's very, very important to have a clearly defined scope and all of your permissions filled out before you do anything. So that if something happens and they say you didn't have permission, you can say, yes, I did, and here's my little sheet that you all signed. Server-based versus agent-based scans. There are two basic ways to access information. One can use a pull method when seeking information. An example, an answer to a question. A push method is more passive. An example, posting information about a restaurant's closing time on social media. Vulnerability scanners have traditionally used a pull approach. Server-based scanner technology. A scanner manager connects to a scanner engine that probes each system for information that is pulled back for analysis. A push option in which software agents that reside on a system send their information back to the manager is becoming increasingly popular. This is known as agent-based scanner technology. Such scanners tend to have less impact on network performance than server-based scanners. Credentialed versus non-credentialed scanners. A threat actor who compromises a network can cause significant degree of harm. A threat actor who also acquires valid authentication credentials, such as usernames and passwords, certificates, and public keys, can potentially cause catastrophic harm. Most vulnerability scanners allow for both types of scans. Credentialed scan. Valid authentication credentials are supplied to the vulnerability scanner to mimic the work of a threat actor who possesses these credentials, can provide a deeper insight into the system by accessing a fuller range of installed software and examining the software's configuration settings and current security posture. Non-credentialed scan provides no such authentication information. These scans run faster because they perform fundamental actions such as looking for open ports and finding software that will respond to requests. Analyzing vulnerability scans involve the following steps: validation and reporting. Validation determines the accuracy of a scan by assessing if the vulnerabilities are genuine. An accurate scan identifies true positives, future attacks that could trigger an alarm, and true negatives, absence of attacks that do not trigger an alarm. False positives versus false negatives. Potential errors in validation scans include false positives and false negatives. False positive is an alarm that is raised when there is no problem. Vulnerability scans may produce false positives for several reasons. Example, scan option may not have been well defined, or the scanner may not recognize a control that is in place to address a vulnerability. Security professionals should attempt to identify false positives. A false negative, failure to raise an alarm in the presence of an issue. This is a more serious issue as the scan overlooked an existing vulnerability that a threat actor may find and exploit. Reporting. Different levels of reports should be distributed to different audiences. Management. Report outlines the impact of vulnerabilities, how the latest scan compares to the previous scan, how serious vulnerabilities are, and the time needed to address them. System and network engineers. Report outlines issues that need to be addressed, lists of devices that have vulnerabilities, and specific details regarding how to fix the problem. Application developers. Report lists the applications that contain vulnerabilities and what those vulnerabilities are. List of vulnerable applications, and, if possible, the location of those vulnerabilities. Security team. Report contains technical security details. Lists vulnerable systems, why and how they could be exploited, and what remediation steps are necessary. Addressing vulnerabilities. The final step in executing a vulnerability scan is to address any uncovered vulnerabilities. Involves remediating vulnerabilities and identifying inhibitors to remediation. Remediation, prioritizing vulnerabilities and taking action steps to address them. Prioritizing vulnerabilities. It is rarely possible and often not desirable to address all vulnerabilities. Not all vulnerabilities are equally damaging. The most important vulnerabilities can be addressed first. The Common Vulnerability Scoring System, or CVSS, can be used as a starting point. Action steps include the following: patch and harden, easiest, quickest, and most economical approach, generally addresses a high number of exposed vulnerabilities. Address difficult vulnerabilities, compensating control, determining an alternative action to a quick and easy situation. Risk acceptance, acknowledging that the risk exists and take no further action. Verify mitigation, involves formally communicating and recording the approved and applied mitigation steps. Create configuration baseline, updated foundation level configuration applied to all systems. Inhibitors to remediation. Include interoperability agreements and formal contractual relationships. Agreements include the following: service level agreements, or SLA, specifies what services will be provided, responsibilities of each party, and any guarantees of service. Memorandum of Understanding, MOU, an agreement between two or more parties. Interconnection Security Agreement, ISA, agreement intended to minimize security risks for data transmitted across a network. and non-disclosure agreements, or an NDA, legal contract that specifies how confidential material will be shared between parties but restricted to others. Other inhibitors can be organizational governance for the company. Organizational governance is a system by which an organization makes and then implements decisions. While the best situation would be for everyone in the organization to agree with the necessity of addressing cybersecurity vulnerability, this is not always the case. Vulnerability corrections may be delayed for an extended period, particularly if they might interrupt normal business processes due to infighting, multiple levels of bureaucracy, or excessive red tape. On some occasions, addressing a vulnerability may require changing or even eliminating function of an application to make it more secure. This approach, known as degrading functionality, can meet stiff resistance if users are accustomed to the function or option. One means of addressing degrading functionality is to remind users of the relationship between security and convenience. As security is increased, convenience is often decreased. That is, the more secure something is, the less convenient it may become to use. Therefore, security is said to be inversely proportional to convenience. I will say that even though you can tell someone this, it doesn't mean they're going to be any happier about it happening. Some organizations are reluctant to make any changes to properly functioning systems. Objections may be raised over taking priority systems offline to address vulnerabilities. Legacy systems. Older systems with specialized software that cannot be easily replaced leads to business process interruptions. The biggest problem with this is it's only a matter of time before either the system breaks down and they're forced to have a much longer period of time that you're going to have to take things offline to find a replacement, or you're going to get attacked through a vulnerability, and again, it'll be down for a much longer period of time. Advanced vulnerability scanning. Computer servers, networks, and endpoints have evolved more rapidly over the last decade than perhaps in any time in the history of IT. Limitations of legacy vulnerability management. Focus on traditional assets. Traditional IT assets are not always designed to discover and scan new assets. Reliance on active scanning technologies. Active scanning tools, while essential, can only capture a snapshot at one point in time. Limitations of scanning. Active scanning tools cannot be used on all systems because of compatibility issues. So if you have like those specialty legacy systems, it's possible that you might have a much more robust scanner that's much further along and it just flat doesn't read that. Limitations, lack of insight and prioritization. Legacy scans do not provide tailored information and actionable steps that allow security personnel to quickly prioritize remediation efforts. Advanced scanning tools and processes have been introduced to reflect the changes in IT. Okay, that's it for this lecture. Have a good night.